Okay. Well, hello everybody from all across the world. This is Deepak, and today I am going to talk to you about the story of India's first mission to the moon and also the first planetary mission ever sent by India. The name is Chandrayaan. So let's understand that first. Chandra means the moon, and Yan means craft. So Chandrayaan was the mission that was sent to the moon. And just like any other mission, every mission has a story. So I will be talking about some of the stories about Chandrayaan as also some of the results that we got from the mission and how they were relevant to the lunar science. I hope you enjoy the talk. So before I go to the Chandrayaan mission, it's always good to provide a perspective from a more human side. So India has connection with the moon, just like many of us, many old civilizations have looked at the moon and imbibed it in different forms. So the moon is a part of our life. It is the single brightest object in the sky that we see every day. So I just wanted to share a few glimpses of the way in which moon has been part of the life in India. We have a lot of deities, and one of the deities is called Lord Shiva. And as you can see in the image, Lord Shiva uses the crescent moon as an accessory. So that itself is, some kind of a observation that people have incorporated even into the deities that they pray. Similarly, the moon has been part of many of our festivals and rituals. I have listed some of them, and I will just say Diwali is one of the biggest festivals in India. So, most of these festivals are associated with the changing phases of the moon. Some of them are on the new moon, and some of them are when the moon is about to go away. And it is just a glimpse of how the changing phases of the moon have been part of the culture of different countries, including India. Another aspect that the moon has been part of is in terms of timekeeping. So, in India, people follow the lunar calendar. However, it doesn't stop just at observation. The moon has also been an object of curiosity and exploration. So, if we look at some of our old scriptures, we find evidence for that. So, I will read out this Sanskrit shlok in one of our ancient scriptures, and then I will tell you what it means. So, it reads like Tvam Som, Som is moon, Tvam Som Prachikito Manisha, Tvam Rajisht Manuneshi Pantham. So translated to English, it says, O moon, we should be able to know you through our intellect. You enlighten us through the right path. So through the ages, people have wondered about what the moon has been like. And today we have the ability to go there and see it for ourselves. And that is kind of the beginning of the story of Chandrayaan. So before I switch to Chandrayaan, I thought I'll just give one slide snapshot of India's space program. It all started in 1963 with the first rocket launch. And ever since, there have been series of rockets that have been developed for various purposes, with the exclusive focus on observation of the Earth. Apart from the rockets, development of launch facilities, tracking of the rockets and the satellites, development of rocket fuel, and scientific instrumentation have also been part of the space science in India. With this background, India made its foray into the planetary exploration with the launch of Chandrayaan 1. It was launched in the year 2008 and was guided primarily by the maturity that ISRO, or the Indian Space Agency, achieved in Earth observation program. There was a need for a new challenge and exploring space further beyond the limits of Earth was the next challenge that they wanted to address. It added a new dimension to ISRO's space aspirations. Besides, at that time in the year 2000, around 2002, there was a growing interest worldwide in going to the moon. And this kind of fits in to the in today's event where all of us are, looking at the moon and trying to understand about the moon. So Europe, China, Japan, and USA all had plans, and all these missions are now either in orbit or have already finished their missions. So it was kind of a space race, and what it turned out to be was a renaissance in lunar exploration, with Chandrayaan playing a key role, both in terms of India's campaign in planetary exploration missions and also towards contributing to the lunar science. And since it was India's first effort, a new generation of planetary scientists were also kind of part of this initiative. And I myself started my career with Chandrayaan. So Chandrayaan 1 was the new kid on the block, but we were not alone. It was an international collaborative effort involving many countries with some of the instruments from our country and many instruments, as you can see here, from UK, Germany, Sweden, US, and even Bulgaria. This effort and the results that came out were rewarded by the International Lunar Exploration Working Group, giving Chandrayaan team the International Cooperation Award, since this was the mission which had the maximum payloads from all different countries across the world. So it was kind of both encouraging and it was quite productive, as you will see in the next few slides. So if I sum up the major contributions of Chandrayaan 1 to lunar science, there was a lot of new information that came around in terms of discovery of globally distributed water species, water detected in the thin lunar atmosphere, detection of ice on the poles, detection of signatures of subsurface ice. We also found evidence for new lunar rock type that was not even found in the lunar samples. And lastly, imaging of a mini magnetosphere, which I'll be talking in the subsequent slides. So these are just some of the major highlights, but what I want you to understand is that these were major discoveries which have actually rewritten the understanding of the moon and beyond. We start with the detection of water in the lunar atmosphere. So the peak that you see here in the plot on the left is for mass number 18, which corresponds to water. And this was detected by an Indian instrument called Moon Impact Probe, which was put on the spacecraft on the advice of none other than the President of India, who was former rocket scientist. So this was the first time ever that water was detected in the lunar atmosphere. And so it was a big discovery, but it didn't stop there. We also discovered water on the lunar surface, and not in only a small part, but it was a global layer of water molecules which was spread all across the moon. So in the image on the left, the blue regions show the highest concentration of these water molecules. And how do we detect them? Well, sunshine falling on the lunar surface is collected by the instrument and split into different wavelengths, just like a rainbow. And that splitting of the wavelengths provides us the signature of the different composition that occurs on any planetary body. So that was the way water was detected on the lunar surface, and it led to very high quality science that was reported in the journal Science, and this image made it to its cover page. So these were the three papers that came out of that research. The interesting part here is that the discovery of OH and H2O, or the water molecule, did not only restrict this discovery to the moon. Actually, it sparked off discovery of these molecules on many other planetary bodies in the solar system. So the impact of this discovery was quite wide. From another instrument using radar, there were potential ice deposits which were detected Here, the circles in green are the ones which were suggested to be bearing water ice, and this water ice was not on the surface but a few meters below it. So, this was another new result from Chandrayaan instruments. And this is the mini magnetosphere. What you essentially see here is a magnetic umbrella that can shield the surface from the harsh radiation coming from the sun. So this was obtained by the SARA instrument, which was a joint Indo-Swedish effort. And coming back to science from the reflected sunlight, I had explained that light shining on the lunar surface is collected by the instrument and split into different wavelengths to give us signatures of the surface. This was used in identifying a new lunar rock type. Here, what you are seeing in pink and red are the signatures of a new lunar rock, which was detected globally, means it was detected all over the moon in very small occurrences. The size is of the order of couple of 100 meters. But then the interesting part was that although we have about 400 kilograms of lunar samples, we don't have this rock type in our collection. So this was a new discovery and it has implications for our understanding of the evolution of the moon. Moving on, we didn't stop at Chandrayaan 1. We followed it up with Chandrayaan 2, which was launched in 2019. So compared to Chandrayaan 1, which uh, orbited around the moon, Chandrayaan 2 comprised of lander and rover apart from the orbiter. So it represented next level of complexity. Unfortunately, the lander and rover could not land successfully, but the orbiter is still operational and collecting data from 8 different instruments listed over here. So this is the image from one of the imaging cameras on board Chandrayaan 2. And on the right is another result from an instrument called Solar X-ray Monitor. And what you see is in the orange line is the signature from instruments, from other instruments. But from the Solar X-ray Monitor, you can see a lot of signal that can be detected from the sun. So it can, apart from looking at the moon, it can also keep a track of the solar activity. And recently, a very interesting paper has come out on this. So I want to end with saying that Chandrayaan started India's foray into the planetary science. It has not ended, actually, it has served as a launch pad for the next set of missions, both to the moon and other planetary bodies. The latest example being Mangalyaan, which was sent in the year 2013, and we are following it up on the moon, back to moon with Chandrayaan 3, with a attempt to land in the polar regions with Gaganyaan mission. I hope now you know about Yaan. Yaan means craft, and Gagan simply means space. So Gaganyaan mission will be India's first human spaceflight mission. We are also planning another mission to Mars. It's called Mangalyaan 2, and and an orbiter mission to Venus called Venus Orbiter. So essentially, the story that I have tried to tell you is we started with our first attempt to go beyond the Earth's orbit to the moon. We did that successfully, and it was followed by a series of missions both to the moon and beyond moon, and we continue that legacy. So I will stop here and take any questions.